In Chapter 18, we're going to write a Python program that randomly subsamples large sequence files, both FASTA and FASTQ. So we're going to call it FASTX sampler here. And there could be a lot of reasons for wanting to downsample files. But I wrote this in my lab at the University of Arizona many years ago, and I thought it was kind of an interesting program to include. And the key idea here that we're going to talk about is non-deterministic sampling. So a deterministic program is one that always creates the same output, and non-deterministic is one that uses randomness, uses probability here for creating the output. So the first thing you should do is go into the top level directory, make sure you do source vnd bin activate to activate the virtual environment. Go into the FASTX sampler directory. You can copy the solution to something called sampler. And if you run the first thing that you will probably need to do is to execute one of the makefile targets called FASTA. And this will in turn run 3 other targets to generate some test inputs for our program that will have 1,000 records, 10,000, and 100,000. And I didn't want to put large sequence files into the GitHub repository. And besides, we went ahead and we went to the trouble of writing a program that will generate sequences for us, test sequences, in Chapter 17 with the synthesizer program. So we're going to use that program to generate these test inputs of N1K, 10K, and 100K. So you should run make FASTA, as I've highlighted here. If you run make FASTA, it will create those 3 input files, and it'll run for just a little bit. This is what it looks like when you run it. And if we want to see how big those files are, well, we happen to have written another program in Chapter 15 where we can use this to give us a sense of what's in those files. Let's run that. And we see there we do have in the 100K, we have 100,000 sequences, 10,000, and 1,000. So that worked, and it helps us kind of build upon what we've been doing before, which I think is kind of fun. So let's run our program. Oh, actually, before we do that, let's just go ahead and run PyTest to verify that the one that we're working with here does actually pass all of the test files, the tests that we've written. So this looks like a good program that we'll be using. So let's see how it works. If we run sampler on this 1,000 1,000 sequences, we see here that it has written 95 sequences to a file in a directory called L. Let's run it again. It again chooses 95, 95. Seems like it's going to write 95. And each time they're going to be a different set of files. And if we look in the out directory, we see that there's one there. Let's run it another time so every time we were running it there with a seed of 1, and let's put a different output file of, we'll just call it n1k.2.fa. And if we do whoops, I think I give that the wrong. There we go. So therefore, you see here, it took this as the input and wrote it to this file, and we see this time that it wrote 111 sequences. So if we take away the seed, we saw that it was always choosing 95. Let's see, it wrote 103, wrote 108, so 91. So you see it's choosing a different number each time, and that's what's going to happen. So if we didn't have access to our wonderful seq-magique program, we might want to count how many records are in that output file. So let's look at the head of out nk1.fa, and we see here it is a FASTA format. I'm going to get rid of there's nk1.2fa. There we go. Didn't mean to write that there. So if we head this file, we see it is FASTA format. So one way that we could count the records is to look for the occurrence of the greater than sign. And we're doing a very simplistic test here. We're assuming that the greater than sign only occurs at the beginning of a line as the input to as the header of each record. But generally that is good enough to work. And if we want to count the number of occurrences there is a program called grep, which I think we've used it once or twice. It looks for patterns of text, And if we were to simply, let's just look at grep without the -c, and we see here that it finds all of the lines that start with or that contain the greater than sign, and we could pipe that into WC-L and we get 91 records. But there's another way to run this, and that is to run it with the -c flag to say that we want to count. We want the output of grep to be just the count of the records that match this pattern, and so it outputs 91. So two different ways to count the number of records there. I do want to point out that there's a little error here that's just waiting to get you. If you were to run this without the greater, without quotes around the greater than sign, you've now run grep-c, and you have used the redirect operator on the command line to then redirect the output from this into out.in1kf.fa. And so now you've just overwritten this file and with the output of this, and then it will print a usage to the command line. That is not what you want, and so you need to make sure, if you ever use this trick, that you always put quotes around it. And this is especially bad if the argument that you're giving is some sort of input file, you know, some huge multi-gigabyte FASTA file that you're trying to count, and all of a sudden you've just overwritten it, and now you have to figure out how to reconstitute your data, which could be difficult. So be careful of that. It has bitten me more than once. So now I'm just showing here that after doing that, I have now a zero length file in there, which is not good. So which is why we have programs like SeqMagick and SeqMagick, so to get around doing things like that. So moving forward, how does the program work? Well, let's run sampler with -h, and we see here that it accepts quite a few options, and this again I feel is more realistic for the kind of programs that I tend to write, Python programs in bioinformatics. The only required input is one or more input files, which are expected to be either FASTA or FASTQ. I do have it basically, I'm not using the guess format. I don't want to say I have it hard-coded here, but it is expected that the user is going to tell us what the format of the files are, and they should all be the same format. And it's going to just default to FASTA. So if they gave us a bunch of FASTQ and they didn't tell us the format, then it would just fall over. So you could, that's a potential way that you could improve this if you want to. This is the important number here, the percentage of the reads that we're going to sample. And so you see here by default, it's going to be 10%, which is represented as a floating point number between 0 and 1. And so this is the first time that we're accepting a float on the command line. And then we have a possible maximum number of reads. So perhaps you want to subsample, you've got several 10, 20 million reads in a file, and you would like to get about 20% of the reads, but you don't want to go more than some particular number. So you could set the percentage to 0.2, but also set a maximum so that it will sample at that rate and then just stop when it hits the maximum. The seed is going to be important, as you've probably already learned. This will allow us to write a program that we are able to test, so that we'll always create the same output if we give it a particular seed. And then the output directory is where the files will be written, and they will be written as the name of the input file into the output file, into the output directory. So that is how our program is going to work. And we see here, here's an example of the maximum. If we run this with the maximum number of records, it's going to sample at a rate of 10%, but as soon as it hits 30 sequences, it's going to stop. And so it's always going to stop at 30. So that can be useful. Here is how we're going to get started. I'm going to start off with new PY to have a brand new sampler. And there's quite a bit to add here, and so I'm not going to make you watch me type it all. So I'm just going to go over here, and I think at this point you should really know how to how to create all these arguments, so I'm not going to worry that you need to go through all this on your own. And so feel free to copy the first part of my program if you want. I think there is some value perhaps in you writing all the argparse stuff here. Let me go through, get rid of this, and let's just talk about this for just a moment. About the arguments and how I created them. A lot of things here you've already seen before, so there should be no surprises. The positional arguments, I usually like to write them first because they're required. And here I'm using indargs with plus to say I want one or more input files. I continue to use the argparse file type, and I will show you how to get around that, although it uses exceptions, which I don't like. And then everything else is optional. So I have provided reasonable defaults for the format. I'm again using choices of FASTA and FASTQ. You could also shorten those to FA and FQ if you want. That could be a way that you could improve your program, or accept all of these options, FASTA, FASTQ, FA, and FQ, and then have it have a good reasonable default. Here is the first time that we are having a type of a float. So we have used type of string is the default for almost everything that we've used, but we have several times used a type of int. What's nice about this is, again, argparse is going to do a lot of validation for us in turning strings that look like floats into actual floats. And I will note here that it can handle scientific notation. So it really does quite a bit of work for us that we get for free. So if you just know how to use this type validation, it's really quite useful. Here we have the maximum number of reads. It's going to be an int, and it's going to default to 0, which is a way you'll see in the code. It's a way of saying, well, I don't have this value set, so don't worry about to checking for the maximum number. I could have left this to none, but then I would just have, if I had not set a default, the default would be none, or I could have specified it as none. It doesn't matter as long as you know how to handle it well. I decided to default to 0. This one, however, is important. The default, I'm being very explicit that the default for the seed is going to be none, because that is basically the same as running with no seed at all. And so I explained this in previous video. So make sure that when you set the seed, if you have a seed like this, you don't default to 0, because then it will always use the 0 as the value, and you won't ever get actual randomness. To get the actual randomness, you need to have no seed at all. And then the output directory, it's going to be a string, and I'm going to show you here if we do not have this as the output directory, if it does not exist as in the file system, we're going to call os makeDirs on that. And I usually handle that inside the get args, so that by the time I hit main, I know that my output directory has already been created. Here's another example of something we've done before. I need to do some additional checking on the percentage. I need to make sure that it is in the range of 0 to 1. Perhaps you didn't know that you could write this kind of chained comparison in Python. So I'm saying that args% has to be greater than 0 and less than 1. And so and if it's not the case that arg% is in this range, then I'm throwing parser error. And the reason why I want to check this here is because if I have access to the parser, and I can call error with this nice error message, and it will generate a really nice output for me. So let's just look at that real quick. Let's say if I run with the percent of first off 0 on test inputs, N1. Let's see, N1K. Whoops, that'll be fine. And so here we see, list is not defined. Good reason for running this. Let's see, optional is not defined. Import optional. And now we have something that seems to run. And if we have a really nice error message here, percent 0 must be between 0 and 1. Here I can let's see, show you a couple of others. Let's see if I put 10 here. That needs to be 0 and 1. I believe here I can put 1 E negative 10. Let's see, and OS. OS is not defined, so let's go import OS. And let's just go down here and start off by printing the arg so I can see what we get here for that. And we see here I put in some scientific notation, a very, very small number. And what we see here is that it was parsed as scientific notation, and it's a very, very small number, but it is greater than 0, and so that passed. And so a lot of things that you're getting by relying on argparse to validate a floating point number for you like that. I'm just curious, I haven't actually tried this before. Let's, unfortunately, not a number is considered a floating point value. There we go. It actually passed. You see here what the error that we triggered is that it passed being validated as a floating point number, but because we had this additional check that it needed to be between 0 and 1, then we actually triggered this error here. So NaN is not a number, and that's actually a valid floating point number thanks to IEEE. And so as frustrating as that can be, you need to be aware that even with validating on the numerical type, you still need to check for not a number, because that could really blow up your calculations. Okay, so we know how to define the parameters to our program, and we seem to have some good inputs now. And I'll just have a little background here on why I went about writing this. And the first point is that there is no inherent ordering to sequences that come off a sequencer. So it may seem like, okay, I've got some sequence files and I want to subsample this. Why don't I just take the first, however many records I want? And so that could work by using, especially if they're FASTQ files, you could just use head. Like if you wanted the first, 10,000, whatever number, just take the number divided by 4, and that will be the number of FASTQ records that you could to take off the files. And as long as if the output is in a FASTA 2 line, which we've looked at, we've seen both FASTA, the regular FASTA output like from BioSeq, that is going to block those the sequences and trim them to a particular 50 characters, whatever is the line length, and make them into nice human readable blocks. We don't need that, though. It's actually a waste of space. It's very rare that any human needs to read the file, other than maybe just to spot check something about maybe the headers or something. So really it's a waste of space to not have FASTA 2 line. And so if it is FASTA 2 line, then sure, you could use head again to take n divided by 2 lines to get the number of records you want. But that's not going to work for multi-line FASTA or for something like a SwissProt file. So you're going to need to write some sort of a parser. But the other problem, and this actually hit me, was that I actually needed to sample from across the entire file. What happened was I wrote exactly the program that I just described for my boss. And the problem was that the input file was a synthetic data set that another friend had made to simulate a metagenome, which is an environmental sample comprised of unknown organisms. So I say here that the input was created by concatenating various reads from known genomes. For instance, the first 10,000 were maybe from bacteria, and then some other bacteria, and then archaea, and then viruses. So just trying to create this mix of organisms that might exist in an environment, and with the goal of putting this into a program that we were writing to see if we could identify those same organisms from scratch. And so if I just took the first N records from that file that my colleague created, I only got 1 or 2 of the organisms that were present. So I needed to sample from across the file all the way to the end. And so that's how I came up with this program. And so one of the first approaches that I had was to, okay, I have some, million reads. I don't know how many I have. So I thought, well, I'll just, start at the beginning, put all the reads into a data structure like a list, find the length of the list, and then divide by, the number that I'm trying to get, say 10%, to find, the reads that I want to take. And I think I did something even sillier where I went along and created a sub list of the positions of every 10th one or something like that. It was really ridiculous, and it used a lot of memory, and it was very slow, and it was kind of dumb. And then I just realized, oh, why don't I just basically toss a coin to determine whether or not I take a particular record. So I came up with a solution that it just reads one sequence at a time and then randomly chooses whether to choose or reject it. And to do that, I randomly select a value from a continuous uniform distribution between 0 and 1. So that means all the values are equally likely to be selected. There are other distributions, normal, Gaussian, all those kinds of things that we could select from. And so I'm going to use a continuous uniform distribution. And to do that, I can import random again. And so let's go look at that. I'm going to make sure I source BMB. Oh, I think I already did that, so I'll just go in here. I'm going to import random, and there is in random a random function that just gives us a random number. And so because it's a uniform distribution, about 10% of the time, this number is going to be less at 0.10 or less. And the other nice thing is that we can, of course, start with a random seed. So it doesn't matter how many times I've called this. If I put random seed and then I call random, I'm going to get the same number. So 134, 122, 134, 122, I got the same number. Very, very cool. So, and if you run this at home on your program, on your computer, using different hardware, probably even using a different version of Python, as long as we're both using the same random module with the same random seed, we should get the same number. So that is the point of random seeds. Very, very cool. So I explained that, random ought to produce a number less than or equal to 0.10 about 10% of the time. Not guaranteed, but it's an approach that will definitely allow me to very quickly decide whether or not to take a record. And in this way, it is going to be a non-deterministic approach to sampling, because every time I run the program, it's going to produce different numbers, and I will select different records. So the reason really, that in and of itself is not the most difficult thing to put together about this program. Really, this is to challenge you to think about, okay, you've got some giant input list of records of files to process. How do you go about writing, a workaday Python program to get through that? And so here I give you a pseudocode idea of how to write the program. And at this point, I feel like I've given you everything that you need to know in order to go off and write a version of this program. And you will learn so much more if you go force yourself to write it. Take a day or two, however long you need to write this, and then come back and see how I did it. So I'm just going to go ahead and go forward. You need to start off by, after you get your arguments, you need to first set your random seed. And I showed you that trick where if you always set it to whatever's in args, args.seed, as long as it defaults to none, then it's the same as not setting it at all if the user hasn't given it to you. You're going to be accepting one or more input files, so you're going to iterate through the input files. You're going to create an output file name that is going to be a concatenation of the output directory and the input file's base name. So I've showed you how to do that before. And that's a clever pattern that I've used just countless times. So it's really good to know how to get a file's base name and to put it with another output directory like that. Then you're going to need to open the output file handle with that output file that you just created. And then for each one of the input files, you're going to initialize a counter for how many files, how many records that you've taken. And that's going to be important under the circumstance that the user has set a maximum number of records, but you won't always need that, but you will always have to write the code to be able to handle that. Then you're going to iterate through each of the records of the input file, and for that I definitely recommend you use bioseq.io. You're going to select a random number between 0 and 1 using random, as I've showed you. If the number is less than or equal to the percentage that's been given to you, which defaults to 0.1, then you're going to write the sequence in just FASTA format, where we're hard coding this value. It's going to be in FASTA format, and you're going to write that to the output file handle. So how do you do that? And then you're going to increment the counter for taking the records so that you know when to stop. If there is a maximum number of records, and the number that you've taken is equal to that number, then you should leave the loop. How do you do that? You should close the file handle, although really that should happen anyway through as we go through the loop. And then to finish off, it's always good to print some sort of feedback to the user so they know that the program is done, how many files were processed, where they can find the output, and all of that. So I would encourage you to run the solution, see what happens, see the output that it produces, and try to produce that yourself. There are several programs that we've written already that you could rely on. I would tell you to go back and look at what we did in Chapter 2, Chapter 15, Chapter 16. There's lots of patterns there that you can use, and that's a key part of why I wrote this book, was to give you lots of sample programs that you could then go back and copy the solutions and use some of the patterns that you've seen before. So with that, I'm just going to go ahead into my solution. The first one is it does exactly what we just talked about. And then the second one, I'm going to show you a couple of modifications that deal with some of the other problems that I've seen in working with large data sets. So I'm going to go ahead and just copy solution to sampler.py, and then we'll look at sampler. How does this work? So, as I said, we're going to start off by setting the random seed. And maybe it's easier to read here. I'm going to set the random seed. And then, well, actually, you know what? Let's just do this. We'll work up to it. I'd rather do that anyway. So the first thing I'm going to do is, and I'll just go ahead and print done here so that we know that we got to the bottom of our program. So I'm going to run sampler on test input n1k.fa, and it's going to do, it's just going to print done. So we're done already. And let's go back and think about how we're going to iterate through all of these. So iterate through each of the input files. Well, we can do that with a for loop. For file, maybe I'll call it fh in args.files, print fh.name. Let's just start there, printing one file name at a time. There we go. Maybe let's do it on all of them so that we have something else, something more interesting to look at. So we're going through each one of the input files and we're printing the name right now. Let's see, the first thing we need to do is set the output file name to the output directory plus the input file's base name. So we know that we can use os.path.basename to get the base name of the file. So this is what it was printing before. If we run it now, we're going to see here, whoops, it says os.path.basename. Sorry about that. Let's try that again. So now it's printing just the base name. Now what I would like to have it is print os.path.join args.outdir, which I know exists because I've already created it. I created it right there. And so if that was unable to work, that would throw an exception and the whole program would have fallen over. So now what I'm printing is out, which is the name, the default name of the directory, my output directory, and the base name of the input file. And let's just change that to out, foo. And now we see here that there is a directory called foo, and this is where the output would be written. So I'm going to get rid of that because I'm going to let it go ahead and be written to out. So that is going to be the output file name that we are going to use. So instead of printing it, I'm going to say out file is equal to that. And then I'm going to say out fh is going to be equal to open out file with write text. And if I run that, let's get rid of that. Now what we see, there should be an out directory, and each one of these, let's see, wc-l on the out files, we see they're all 0 length because they've all been created they've all been opened, and so they've been overwritten. So each time that I run this program, they're going to be overwritten. So now we've taken care of the first two here. We have an output file name, and we've opened the output file handle, and now we need to initialize a counter for how many records have been taken. So I will just say num equals 0. I usually like to say something like num taken is equal to 0. And now I need to iterate through each record of the input file. Well, I know for that I'm going to use from bioseq.io. Yes, I've already got that imported. So I'm going to say for rec in seq.io.parse, and it's going to be my file handle, and I'm going to parse this in, args.format is going to be, let's print rec and then break, just to make sure that I can print the first record from each one of these. There we go. Args.format, I called it file format. So again, here the idea is that we're just changing one thing at a time and then looking at our program how it changes. So I have now parsed through each one of the input files, and I printed the first record from each one of them. And we see here I'm printing rec, and we see here this familiar string version of the FASTA record or FASTQ record that we're using. And it has the sequence here, and it's this sequence object. So now we're iterating through each of the records of the input file, and I need to select a random number between 0 and 1. I don't remember what I called it in my program, so let us just, we'll just say val is equal to random.random. And what I need to do is I need to determine if this number is less than or equal to the percentage. I don't actually need to put it into a value. I can just say if random is less than args.percent, then I'll print the record. And for that, now let's run our program. And we see here it is printing things, and it's only printing them sometimes. And maybe it would be easier if we only use our first one, 1K. And it would be nice to know which numbers that we're printing. So we'll figure that out here in just a second. So if that number is less than or equal to the percentage that we're supposed to take, we're going to write that in FASTA format to the output file handle. So how do we do that? Well, I'm going to use, instead of printing, I'm going to say seq.io.write. And I can never remember exactly how to use this, so I'm going to from bio import seq.io, and I'm going to say help seq.io.write, and it's going to tell me hopefully what I want to know. The argument is the sequence, and then the handle comes second, and then the format comes third. So the sequence is going to be my record, a list or iterator, or a single seq record, and then the handle is going to be out.fh, and then the format is going to be hard-coded. I'm always right now just writing these in FASTA format. So with that, let me try that again. Now it doesn't give me any feedback, but if I run that wc-l on out, I see here the other two are still exist because I haven't gotten rid of them. But now we see there are 357 lines in out NK1FA. Let's look at that file. We see here that it is in regular FASTA format. What if we change this to FASTA 2-line? Let me just run it again. Look at the WC real quick. Now you see it's only 222. And if we look at that file again, now we see it's in FASTA 2-line format, which is probably what I prefer. But since I wrote the program to be FASTA, I'll leave it that way. So now we have done this much. let's see, we have written the sequence in FASTA format to the file handle. Now we need to increment the counter that we're using for taken. So we need to say num taken is plus equal to 1. So it's going to be greater than by 1. And then so we could actually say print num taken here so that we know how many was taken. That would be useful, and we're going to have a better output here in a little bit now. But now we see that we're in the range of 1,000. I mean 10% for given 1,000. We're printing around. We're taking around 100, but we're taking a different number each time. If we run this with a random seed of 1, then we see that we're always taking 95. And if we run this with 2, then we see that we're always taking 90. Every single time, and we'll always be taking the same 90. So you see here we're getting close, but we're not always hitting 100. Let's find if we can get one that is always, okay, so if we take 3, we're always taking 103. So we want to then therefore set a max of 100. And we see here that we still went and took 103. So we need to also take into account that if there is a maximum number of records, then we need to leave the loop. So we can say if num taken, well, let's see, if args.max reads and num taken is greater than or equal to args.max reads, then we need to break out of our loop. And then, therefore, we should see that we always take exactly 100, even though under the conditions of 3, we wanted to take 103. So we've now basically written the whole program, and the last thing to write is some statistics to let the user know exactly what was done on their behalf. And if we go look at the solution here, how close did I get to exactly how I wrote it? Well, one of the things that I did here is I gave a little more feedback while I was processing the input files. And I do like that. So let's, and there's a couple other things I did here. I want to be able to print the total number that I took. So as far as like making my program nicer for the user, these are some things that I decided to add in. So I'm going to tell them the total number that I'm printing. I would also, as I'm processing these, I would like to let them know the progress. And we saw here in the program that wrote, some reports that we were able to use the rich modules track bar, which created a nice little, growing progress bar. In a lot of times, I will just usually enumerate over some input values, and I usually like to say start is at 1 so that I don't have to add 1 to it. And then, so therefore, I'm going to use I, which is usually a terrible variable name, except in the case of iterating over numbers, integer values, and using them as counters. So in this very, very limited use case, I'm going to use I. And so therefore, what I want to do is print the name of the file, the base name. Let's say looks like I put it into a variable here, which is fine. It's a good way to do it. So let me put that there. Sorry. And I called it base name is equal to arg.base name, and then so I'll concatenate that. And so there we go. I have a little bit more input here, a little more. I know a little bit more about what's going on as the program is going, and so let's just run this real quick so that we can see how our program is working. We'll run it on the N1s, and so we see here that's what we're getting is we've added this enumerate so that we know which file number that we're working on, and we print the base name so that the user has some feedback. So what else did I do here? Solution is what I'm going to open. So with that, I have a little more feedback. If random is less than or equal to, oops, I said less than. I should say less than or equal to %. That didn't trigger an error, but If it's true that, that this is within the range of what I want to print, then I'm going to write, and I had to go look that up, but I came up with the same solution here. And then the same kind of check here, if that args reads. So I'm just saying if args.max reads. I'm just able to, I don't have to say, let me show you, I have actually seen this written before, if equal to true. I don't need to say that. I just need to evaluate it in a Boolean context. And so if it's true, then that will be true. If it's 0 or if it's none, then that will be false, false-y. And so if this is some true value and the number taken is I said greater than or equal to, really the trigger will just be when it's equal to the maximum number of reads, then we want to break. So, and I need to make sure that I increment the number taken in order to get that to work. I said here, to be pedantic, that you should close the file handle. And so let me just show you how to do that. You can call the close method on your output FH. And you notice here, in both instances, I use the variable name outFH. To FH to remind me that this is a file handle, and then this is the output file handle, whereas this FH is the input file handle. Just naming conventions that I always use that help me remember what I'm doing. And so that is how I came up with that. I call outFH close just to be, very, very certain that it will be closed, but really because we're in this for loop, the file handle will fall out of scope the next time we come into this for loop. It will be reinitialized as a new one. So we don't really need this, but it is good to know how to close a file handle in case you need to. The other thing that I did here was this number taken is for the individual file, but I want to add that to the total number that I take just for the output here. And so in the end, I would like to be able to say, that I wrote some total number of sequences, right? Something like this. And so that'll be an F string, and so I'll get rid of that. And let's just look at this, how it works. So if I run my sampler on tests inputs, start.fa, what we'll see is, first off, that's not a very pretty way to write this. So let's go over here and let me show you a couple of. Look at the solution. A couple things that I've done here is to first off figure out how many files that I had by looking at the length of args.files. So let's look at sampler, and I can add this here so that I can use that. But the other thing I want to show you here is, first off, how can I put a comma in there? Well, one of the nice things in Python is that you can add some formatting information in this placeholder after a colon. And if I use the format of a comma, then let me show you how that affects it. You see here now it put a comma in there, which is the way that we separate the thousands blocks in standard English, or at least in America. In the United States, if you're in maybe a European country that uses a period there, I'm not exactly sure how you would do that, but you could certainly format this to whatever is your locale. So that's an additional piece that I want here. So I really want to say I wrote the total number of sequences, and so this is something that always bothers me. Let's say I put a max of 1. Wrote let's just choose one file in 1K. And now it says wrote 1 sequences, and that just bothers me to no end. I do not like that. I was originally an English major in my undergrad, and that needs to say wrote 1 sequence. And so I have this little bit here where I'm using an if expression, which I've shown you before. So let's go look at how that, instead of typing sequence, I'm going to say wrote some total number of sequence. Sequence is always going to be printed, but and I'm going to change this to single quotes. And I'm going to say inside after sequence, what's going to be printed is the empty string if the total number is equal to 1, else it's going to be an S. So let's look at how that works. Now it says wrote 1 sequence. Let's say the maximum of 2, wrote 2 sequences. Let's say the maximum of 0. What are we going to do? Wrote 0, yeah, 112 sequences. So that is the way that I get that to look a little nicer, and I just think it just looks really, really nice. So now I'd like to say how many files I printed from. So from the number of files, and I'm using that same trick of a comma there if it happens to be a large number of files. So let's go run this on in FA, and we see here. Oh, I need a space here, so let's add a space here. So wrote 11,001 sequences from 3 files. Okay, very good, but I don't know where the output went. So the last thing I'm going to add is to the directory, and then I'm going to say args.outer. Let me save that. And unexpected indent. And it is simply, I can use set list. Whoops. And I'm not sure. Oh, it's because of that. Got it. I had an extra parenthesis. And now with that, I should get a nice summary of what happened, how many sequences were written from how many files to what place. And then if I do WC-L on out, I see out star. I see here that it has a particular number. Let's go into the 15 seq magique. Let's run seq magique on out star, and it tells me the stats here and how many sequences were taken from each one of these files, and that is useful information. So that is a very typical kind of program that I would write in bioinformatics, and I should verify that this my version does pass all of my tests. So I have a pretty decent test suite here that exercises bad inputs to the program. You see here the way that I tend to write my tests is that I put all my bad stuff up front, and then I test on one file, I test on some FASTQ input, I test on multiple files, I test the max reads, and I test some other options. I would definitely recommend that you go read through all the tests that I wrote as well. So let me just talk a little bit about a couple other things that this program brought up for me as I was writing. I've talked here about the argparse file type, and it is deprecated as of recording these videos in 2026. It was not deprecated when I wrote this book in 2022, whenever that was, 2021. And so this can actually cause problems in the case of, like, say, you have a lot of input files. And so it might be the case that it would be better for you to declare this as a string. You could still put this, the metavar is going to be file. And one trick that you could do is I do something like this quite a bit, is I iterate over all the args.files. So I could do this inside, and let's just look at what that would look like. So I have my sampler here. Let's change this, instead of files being text.io, it's going to be files, it's going to be a list of strings. And this is no longer going to be we're not going to rely on argparse to do those as file handles. And so we could add this little bit of code. Let's look at how that would work. We go through here. After we've parsed the args, I'm going to go through args.file, and I'm going to say if it's not a file, this is going to be this is a list comprehension with the guard, and the guard is that the thing is not a file. If for all the ones that are not files, that's going to be returned as bad files. I'm using the walrus operator, so that if they're all good files, then this will return an empty list, and then this will evaluate to falsy, and it won't be triggered. But if there is some bad input file, it's going to trigger this. It's going to, bad files is going to have a non-zero length, and then therefore we'll go through here and we'll print that these are the invalid files. So let's just look at how that would work. If I say sampler on foo, bar, and baz, then we should get invalid file foo, bar, baz, because those don't exist as input files. Let me put in here foo, bar, test inputs 1K, and we see here only foo and baz were taken as invalid files. That would then cascade down into args.files. This would not be a file handle, it would be a file name. And then therefore I would say file handle is equal to open.filename. Something like that. And that would work too. And then I think from here there should be no problem with our program going forward. It should work just fine from there. We are still having no FH name. I have to change this file name. Oh, actually that should have worked. No such file or oh, the problem is what is happening here is that in my test suite, when I ran with a bad file, so that would work actually. That was not a problem. That was the problem is that the error message that the program is creating now is not what it was expecting. So if we run sampler on, foo, then what's happening is that it's creating this as the error message, and which is not what's expected by the test suite. And so that's why my test is failing. But my program should actually still work. Let's just run sampler on test inputs in 1 star, and we see here it still creates that. If we run the that, we still see that it selected some number of reads, and so this is another way of writing this program without relying on argparse file type. And I have a note here that that in one of the programs that I wrote, I had to parse 350,000 XML files I was writing a mirror of the clinical trials database from the FDA, and so I had to download every week this huge database dump that was given to me in XML files. And so when I used file type, then my program first started by opening 350,000 input files, which exceeded the number of file handles on my file system. So this would be a way of not using file type and then just opening them yourself, which is arguably probably faster, but you lose that nice checking. So this is a way of adding your own checks, and then therefore you at least know from this point forward that you have files that exist on the file system. Now you still may not be able to read them. They may be zero length, they may not be usable data, so there's some additional checking you might have to do, but at least you know they are files. And I like to do this this kind of a check in getargs because I would then have access to parser error to throw a nice error message like this that includes the usage of the program. Another thing that I would like to point out is that sometimes you have gzip data. You actually probably should have gzip data because these sequence files are just huge. And so storing them in an uncompressed format is generally a waste of disk space. There's a lot of times you just don't need to have them in uncompressed format. So let's go into test inputs real quick and let's gzip. I can't remember if I can do star like this. So I'm gzipping them now. So they are now quite a bit smaller than they were before. I should have showed you what the sizes that they were before. But now I have this problem that I can't like head in 1K gzip, right? It looks like this garbage. It's this binary format. So I can say gunzip -c actually on N1K, and I could actually pipe that into head, and that is a way of actually inspecting the file without having to uncompress the whole thing. So if I were to say gunzip the N1K, then I actually have to completely unzip the file. Now the entire file is unzipped in order for me to do something like head on the file, which is not at all what I need to do if I know about gunzip-c. Instead of gunzipping the file, if I gunzip-c the file, then the file still exists in gzip format. All I've done is just streamed the output of gunzip. And what's cool about this trick of piping it into head is that it could be an enormous file, and head will break off the stream to the first 10 lines. And so it won't unzip the entire file. It will only unzip as much as head needs to consume. And in this way, basically, you're using a lazy function, which is something that we've talked a lot about in Python. So it would actually be much better for the files to exist in a compressed format on your file system. And if you need to visually inspect it manually, you can use a trick like this to look at them. But then the question is, do you need to unzip them in order for Python to read them? No, you do not. There is actually, and I show here, let me find this. One of the things that you could do is get the extension of the file. So for instance, what we're going to do here is we're going to import gzip, the gzip module. And so we've got the base name here. Instead of just opening the file handle, the first thing that we need to do is figure out the extension. I've showed you here how to do that with split ext. On the base name, that's going to split it into the root and then the extension. We only want the extension part. It's going to return a tuple, so I'm going to use subscript 1 to just get the extension. And my file handle now, if it's the case, I'm using a really basic heuristic here, that if the extension is equal to .gz, which is typical, then we're going to gzip open the file. Otherwise, if it's not, we're going to, if it seems to be something, if it's anything other than .gz, we're just going to use our regular open. And from there, we don't need to change anything else about our program. So let me show you how that looks. Let's gunzip the first one, n1k.fa. Let's go back, and now let's run sampler on tests inputs n star. And let's see, we are actually getting a problem here.